make sure you see that.
This is Tim here. I hope you're doing well. This is a quick video for my students on what torque is. Look at this beautiful setup I'm after making for you, alright? I got this nice crank handle from McMaster Carr. It's connected to an input shaft that goes to a spur gear that has 20 teeth, which meshes with a gear that has 40 teeth. So this is our input shaft. This is our output shaft, which is connected to an arm. The arm length is 1 foot, and it's connected to a nice force gauge which I got from Amazon. We're going to attach, go on John, we're going to attach a 5 pound weight on the crank handle. Now our total weight, our total force is going to be 5.5 because we're going to add a half a pound on this crank handle. Now our moment arm from the handle to the pivot point is 6.5 inches. So do you remember torque is force times distance? So because we have a crank handle and we have a force, we're creating a torque on this shaft. So how much torque are we producing on the shaft? We have 5.5 pounds multiplied by the distance, which is 6.5 inches. If we multiply the two of them out, we get roughly 36 inch-pounds. If I divide it by 12 to get it in foot-pounds, I get roughly 3 foot-pounds of torque. So I'm creating 3 foot-pounds on that shaft. I have a pair of gears, which is going to be a torque multiplier. I'm going from a small gear to a large gear. This is 40 teeth, that's 20 teeth. So the output torque is going to be 3 foot-pounds, which is the input torque, multiplied by the gear ratio. So I should be getting 6 foot-pounds on the output. I'm getting twice as much torque. So I should be getting 6 foot-pounds on this bad boy. The arm is 1 foot. So if I look at my force gauge, it's back to front now, but it's upside down. That says 6.1 pounds of force. John, am I explaining that well? You're happy with it? Can you add anything to it?
No.
So look, it's doing what it's supposed to do. The gears are multiplying the torque. And why, John, tell him this. Why do I have to have an arm here? What's that arm about?
Well, torque is force times distance, so you need to create the distance. That's what the arm does. So he's anchored to the shaft, and he's anchored at 12 inches away from the pivot point, and that gives you your force.
So tell him, if we wanted to produce more torque, how can we produce more torque in this system?
Well, there's two ways. Either you apply more force at the input end, or you change the gear ratio and use a smaller pinion or a bigger driven gear.
Ah, yeah. Now it's nice. I bought these weights years ago. This is the first time they've been used. All right. So I hope that makes sense.